So previously Samuel presented the comparison between feed-forward and feedback control. And now I'm asking you to explain why or how can you implement a feed-forward control. What is the difference when you have a feedback control and once you want to implement a feed-forward control? What do you need to measure in addition? What do you need to measure? What is the new variable that you need to measure in this case? Okay, go ahead.
The problem, a problem identification develops on model mathematical for two flotation cell. The simulation is carried out with P controller, which feed into the next cell controller.
A simulation carried out with a PI controller, which feed into the next controller. It's a PI controller. Yeah.
PI.
So what is the problem at the end?
The problem is carry out with PA controller, which feed into net cell controller.
Yeah, but it's not quite clear what are the problems that you're trying to solve. The problems are, for example, interaction between cells.
The cells
Lack or you don't have coordination between controllers. Each controller works independently. So it generates a problem. So if you are moving one level in one cell, you are affecting the other one because they are interconnected. That is one of the problems. There are a list of at least 6 problems as presented somewhere previously. So you need to improve problem identification. There are more problems. For example, the cell geometry is not a cylindrical cell. You have different geometry, so it's not longer linear. For example. Okay.
My models, mathematical model of flotation cell series, single cell in series DB dt equal Q level if 1 equal Q by QCD.
Why do we have different levels? This tank is above this one. This is in a lower level. Why the flotation cells are configured in a different levels? This is in a lower level. Next one, I presume, is in another lower level. Why?
Why different level? The control one first tank. This two tank. This tour no effects. The level the two tank.
No, actually they are completely connected systems. So if you increase liquid level here or pulp level here, you increase the pressure, and then you have more flow rate going here, and then will affect the second tank. They are connected in different levels because you feed the second stage by gravitationally. They are connected like that because you need to feed first tank, fill the second, and the second the third, and so on. So they are connected like that because you don't want to have a pump in between. You don't need a pump in between. So if I increase the level here, it will fill the other tank gravitationally. By gravitation, they are connected. Results.
Feedback control by this tool and open valve. Control is.
Are you sure you test the controller opening the valve? I think it's in a closed loop. I mean, you just change a set point. You are not making a. It's not an open loop test. It's a closed loop test.
Close.
Oh.
One result. The control system and feedback control. See here.
This is the response.
This is the response
for a feedback control.
For feedback control.
When I change a set point. No, when I change a set point. And the second, on your right hand side, you have the same response with a feed-forward control. Conclusions.
The gain with different character, valves, cells, etc. Similarly, the proportional gains were large in the case of tank with cells, overshoot % deep time. Yeah.
What's the main conclusion then?
Both an overshoot and deep time are decreased.
Where decrease? In what case?
In what case?
In the case of
feed-forward control.
Feed-forward control.